One, Mr. Duy Dong Lê.
Yes, yes. Thank you, Ms. Chairwoman. Can you hear me clearly?
We hear you clearly.
Okay.
Just say,
Good morning from Vinlong. Ms. Chairwoman, my distinguished colleagues, and outstanding researchers. On behalf of Kiều Trinh and me, I'm going to present to you an overview about federated learning for heterogeneous data. Look to the introductions. You can look into the screen. This figure show the traditional single machine learning method we have widely used in the past, and we have to collect the data and store in the database, and then you build such kind of model. For example, deep learning neural network with many layers, and each layer has many cells. And after the training process, you got the wave. It means the model update. But the question is, where is the data? Where do we get data to do the data analysis? The answer is we have to transfer data from another location. But today, transferring data another location to our machine is not very easy. I will tell you later. And the traditional machine learning approach has faced many drawbacks. The first one, if the server, I mean the machine to do the machine learning configuration is not very good, it's gonna be a bottleneck of the whole system. And with a single model, sometimes it's fell into local optima. And the more importantly, many other countries nowadays don't want us to move the data from their country to another location. For example, in Europe and China and Vietnam, I think Vietnam is going to be banned. So to deal with that problem, federated learning was born in 2016 by Mark Mahan, uh, computer scientist at Google. He invented centralized federated learning as shown in the figure on the left, with a server and a huge number of clients. Each client has their own data, and in the training process, clients don't need to send the data to the server. Instead of that, you send the model update. And then the server aggregates a global model and the global model and send to each client. The algorithm of the whole training process is in my paper, you can read. And one of the usage of federated learning was found in 2018 by another scientist of Google. Um, it's called a mobile keyboard typing prediction or autocomplete that we use every day of billion people in the world. For example, when you text somebody in Jello or Messenger or Viber, you type a sentence. For example, I had such age, and then the keyboard suggests for you some next word. For example, I had a great, or I had such a great time, or I had such a lovely, for example. I believe that most of us use it every day. And this application was based on federated learning. And now move to the architectures of federated learning. The figure you have shown in various slides is about centralized one. And here is the decentralized federated learning. Because centralized federated learning may cause a very high communication cost on the whole system. So federated, decentralized federated learning instead of sending the model update to the server, the client here to send to exchange the model update with its neighbor, just neighbor. Okay, so it's reduced the communication cost. Another architecture is hierarchical, or we call tree. So it is the combination between the centralized federated learning and decentralized federated learning. So uh, hierarchical federated learning is known to solve the heterogeneous data and the, the high communication cost of the whole system. And next, I want to mention about the multi-model federated learning directions. In multi-model, each machine may train set many kind of model. Sorry, I hear something. Somebody is saying. Each client train another kind of model. For example, you can see in the client one, just one model. Client two has three models. Client three has two models. And client K, three models. The most important thing is that the server has all the model that client has. Okay. And once again, the algorithm for multi-model federated learning is in my paper. You can read it. And here is the algorithm. So now is the domains for federated learning. Federated learning is widely used in real life. For example, this is the mobile application I have told you before by heart and limbs. And in healthcare, healthcare is the most widely used by Ricky. This is the survey. All of the paper here is the survey. You can read in my paper. And for smart city, okay, smart city with IoT sensor, and for security, for smart security. And I have just published last month a paper about air quality index. It's just a survey about federated learning. And here is I want to mention about some benchmarking for you to implement the federated learning. The first one is TensorFlow federated learning. If you're familiar with Google Colab, maybe you're familiar with TensorFlow. But TensorFlow federated is a bunch of algorithms you can use to implement to experiment your project. And another benchmark is Leaf. Leaf is a combination of um, data, many kind of data. You can be the benchmark. And here are some challenges of federated learning. The first one is the communication cost in the network. So we have to find fast convergent algorithm, or we can make as small model updates as possible to reduce the communication cost. And the second one is the main idea of this paper. It's about the heterogeneity. Uh, to deal with the heterogeneity of the system, we have to develop a client selection solution. And to deal with this diversity in the data, the multi-model federated learning should be considered. And the third challenge is not only for federated learning, but also for the machine learning and AI. We know that deep learning model architectures we have to prefix For example, how many layers, how many cells in each layer, and how many e-bars, and uh, how big the bar size we have to prefix. That is very not very good for our task. So we have to find neural architecture search, or we call NAAS, to find the appropriate deep learning architecture for each task on each client. And this is my conclusion. So federated learning is a young algorithm, but it is an advanced mechanism. It can solve many problems in real life. For example, can avoid local optima and the heterogeneity of the data. Maybe it enhance the outcome of the model. And the most important thing is that it ensures the data privacy and security. Mm, the A new directions of multimodal federated learning should be considered by computer science community in the future. So this is the end of my presentation. And thank you for your attention.
Thank you, Mr. Duy Dong Lê, for your presentation. It's finished on time. So now I would like to invite the discussion. Here we have allocate the discussion from the group of Nguyễn Ngọc Lan Phương. So do you have any idea to comment or contribute to the paper of Mr. Duy Dong Lê? Hmm? Good morning, Mr. Duy Dong and Mrs. Kiều Jin.
Yeah.
Yeah, I'm Lam Phương Nguyễn Ngọc, and I would like to ask you two questions about your paper. So the first is, among the three mentioned architectures of decentralized learning, which one do you think is the best suitable for working with data on mobile devices, and why?
Okay. Thank you for your questions. Uh, so let me move to the slide of mobile applications by heart in 2018. This application was based on centralized federated learning, and it's successful applied to real life. We use it every day, but I think we have to. I think for training such a huge, in mobile keyboard, this application they train with more than 2 million mobile phones, 2 million mobile phones around the world. So the communication cost and the time of processing it takes very long. So I think we should change to the architecture of hierarchical. Yes, I think. Thank you.
Thank you for your.
Thank you so much.
So, how about another one? Do you have any idea or comment from another group, another author? Hello. So, can you discuss more about the application from your result? How can you apply, and how about the benefit?
This is just a survey. I survey from other review paper. And the application, I think the most widely used of federated learning is now the healthcare because um, uh, the data of the patient in the hospital is not private. It is hard to get in touch with the data. So they most of the hospital uh, they use the federated learning to prevent the data moving outside, moving out of the hospital. And then the new another branch of research is now about air quality index. Okay, thank you.
Yeah, thank you.